Jai Hind students, welcome to my YouTube channel. Students, in order to succeed, the desire for success must be much more than the fear of failure. So with that students, let's start today's session. In this particular session, we will be discussing the analytical treatment of parallelogram law vector addition. In the previous lecture, we have discussed triangle law vector addition, we have discussed its analytical treatment, and we have discussed the various cases. Same results will be obtained in case of parallelogram law vector addition as well, because as we have discussed, parallelogram law vector addition is simply the extension of triangle law vector addition. So let's recap the statement of this law and then we'll proceed with its mathematical or analytical treatment, right? So, parallelogram law vector addition, this is the law which is applicable so as to find out the resultant, its magnitude, its direction when two vectors are inclined at a given angle, right? Suppose A vector and B vector are acting at point O on a particle simultaneously, and let theta be the angle between A vector and B vector, right? Now, parallelogram law vector addition states that if these two vectors acting at a point or particle simultaneously be represented by the two adjacent sides of a parallelogram acting at a point, then the vector resultant of these two given vectors, both in magnitude and direction, will be given by the diagonal of this parallelogram passing through the same point. So that's the statement of parallelogram law vector addition, right? So this is how I have constructed the parallelogram. Dotted line suggests that it's done through construction, right? These are equal vectors, this is A vector, this is the equal vector. Equal vector, as we are aware, both they are of equal magnitude as well as same direction. This B vector, this is also B vector. In a parallelogram, the opposite sides are equal as well as they are parallel, right? Theta, this is the angle which A vector and B vector makes with each other. Beta, this is the angle which the resultant makes with A vector. Clear, students? Now, in order to proceed, what we do is consider this to be point small a, this to be small b, this to be small d. And what we do is from point B drop a perpendicular, right? Drop a perpendicular and produce OA such that both meet at point say B. This is perpendicular. Clear, students? And if this angle is theta, this angle would be also equal to theta. These are the two parallel lines. This will act as a transversal. So these are the pair of corresponding angles. I hope diagram is pretty clear. Now what we do is we'll consider the right angle triangle, the bigger one. So in right angle triangle ODB, we are considering this triangle ODB. It's a right angle triangle. We can very much make use of Pythagoras theorem, which is the square of the hypotenuse is equal to the sum of the square of the base and the perpendicular. So what we get is OB square is equal to, this is hypotenuse square, is equal to base square OD square plus perpendicular square, that is BD square. So OD may be further written as OA plus AD, isn't it? So OD may be written as OA plus AD. So it is in the form of A plus B whole square. We can expand it. So we get OA square plus AD square plus twice OA AD plus BD square. Clear, students? Now what we do is AD. Look, this is AD. We need to represent AD in terms of B and theta. So for that, what we do is in this triangle, in triangle ABD, in this triangle ABD, consider cos theta. Cos theta is base over hypotenuse, that is AD divided by hypotenuse is AB. So what you get is AB is equal to AB cos theta. Right, students? So here in place of AD we can write AB cos. So now let's try to rearrange the terms. What we get is OB square, it would be equal to OA square plus AD square. Let us take these two terms, plus BD square plus twice OA, and in place of AD we can write AB cos theta. Right? So OB square is equal to OA square plus, consider these two terms. In this right angle triangle, this is again a right angle triangle, so we can very much make use of Pythagoras theorem. So this is hypotenuse, this is base, and this is perpendicular. So AB square, it should be equal to AD square plus BD square. So AD square plus BD square may be written as AB square plus twice OA AB cos theta. Clear, students? Now let's substitute the value. We are aware the magnitude of OA is A. The magnitude of OC is B, isn't it? The magnitude of AB is also equal to B. So let's substitute the value. And the magnitude of OB, which is R. So what you get is R square is equal to A square plus B square plus twice A B cos theta. Theta is obviously the angle between A vector and B vector. So the magnitude of the resultant is given by square root of A square plus B square plus twice AB cos theta. So whenever the two vectors are inclined at an angle theta, then the magnitude of the resultant is given by R is equal to square root of A square plus B square plus twice AB cos theta, where theta is the angle between the two given vectors, A vector and B vector. So this is regarding the magnitude of the resultant. Now students, look, here resultant R makes an angle of beta with A vector. So beta gives the direction of the resultant. So let's find the direction of the resultant. So for that, what to do is consider this big triangle. Consider triangle OBD and consider tan beta. Tan beta is equal to perpendicular by base, that is BD divided by base is OD. Now it can further be written as BD base OD, it may be written as OA plus AD. Clear, students? Now as I have told you, we need to represent the magnitude and the direction of the resultant only in terms of A, B and theta, which is the angle between them. So BD, this one is BD. We need to change it in terms of B. So what to do is, if in this small triangle, if you consider sine theta, what we get is perpendicular by hypotenuse, that is BD divided by hypotenuse is AB. So what I mean to say is that BD, it may be written as AB sine theta, isn't it? So tan beta, it will give us, in place of BD we can write AB sine theta. It is AB sine theta divided by OA plus AD. AD is equal to AB cos theta. It is AB cos theta. Now let's substitute the value. So what we get is tan beta is equal to AB. AB, its magnitude is B. Sine theta divided by OA, its magnitude is A. Plus AB is B cos theta. So this is the expression which will give us the direction of the resultant. So these are the two very, very important results. These two gives the resultant both in magnitude as well as in direction. Right? So that's the analytical treatment of parallelogram law of vector addition. So before we start discussing the special cases as was done previously, let me recall or let us repeat the statement of parallelogram law of vector addition. The students, I repeat, if the two vectors acting on a particle simultaneously be represented by the two adjacent sides of a parallelogram acting at a point, then their vector resultant both in magnitude and direction is given by the diagonal of the parallelogram passing through the same point. So here R vector is equal to A vector plus B vector. You can consider this triangle, right? And these are the two sides of a triangle taken in the same order. So A vector plus B vector would be equal to the third or the closing side of the triangle taken in the opposite order. So R vector is A vector plus B vector. So basically, parallelogram law of vector addition is simply the extension of triangle law of vector addition. Nothing new in it. So all the cases, all the mathematical expressions, whatever we are obtaining is simply the same as was obtained previously in the case of triangle law of vector addition. Right? So students, let's work out on the special cases. So case 1, we'll consider the angle between the two vectors to be 0 degree. Then let's try to find out the resultant, its magnitude as well as direction. So let me write down the formula first. Regarding the magnitude, it is given by square root of A square plus B square plus twice AB cos theta. And second, its direction, tan beta, it is equal to B sin theta divided by A plus B cos theta. These are the two formulas which we have derived just now, right? So, special cases. Let's consider case 1. Case 1 is when the angle between the two given vectors is 0 degree. What will the diagram like? It will be like this. This is point 2, this is A vector, and this is B vector, right? This is A vector and B vector, both are coincident. So the angle between them is 0 degree. So here if you substitute, what will be the value then? Resultant, it will be given by square root of A square plus B square plus twice AB cos 0. Cos 0 students, it's 1, isn't it? So it will be in the form of A plus B whole square. So resultant would be square root of A plus B whole square, which is equal to A plus B. So simple. What's the conclusion? Whenever the two vectors are acting in the same direction, then the resultant, its magnitude, would be given by sum of the magnitudes of the two given vectors. Right? What about the direction? Here tan beta. It would be equal to B sin 0 divided by A plus B cos 0. Sin 0 is 0, so it will be equal to 0, which implies that beta is equal to 0. So the resultant will make an angle of 0 degree with A vector. That is, it will be along the direction of A vector. Clear, students? So this is case 1. Let's consider in case 2. When theta is equal to 180 degree. Now, what will be the diagram? This is point 2, this is A vector, and this is B vector. Now, for 180 degree, it will be like this. It will be in the opposite direction. So, what's the angle between A vector and B vector? It is 180 degree. So, here the magnitude would be given by square root of A square plus B square plus twice AB cos 180 degree. Cos 180 degree is minus 1, so it may be written as square root of A square plus B square minus twice AB. So it can be further written as A minus B whole square. That is, resultant would be given by A minus B. Here, A is considered to be greater than B. So what I mean to say is that whenever the two vectors are oppositely directed, the angle between them is 180 degree. Then the magnitude of the resultant is given by the difference in the magnitude of the two given vectors. And what about the direction? The direction of the resultant will be along the direction of the dominating, that is the larger vector, isn't it? Here A is greater, so resultant will be along this direction. Clear students? You can substitute the value. Sin 180 is 0. So tan beta would be equal to 0. So here tan beta, it would be equal to b sin 180 divided by a plus b cos 180. Sin 180 is 0. So 0 divided by anything will be 0. So beta would be equal to 0. So in this case, the direction of the resultant will be along the direction of a vector, which is considered to be the dominant one. Clear students? So case 1, case 2. When theta is equal to 0 degree or theta equals to 180 degree, both the cases are over. Now let's discuss the third case. Third case is when the two vectors are mutually perpendicular to each other. That is, when the angle between the two given vectors is considered to be 90 degree. Right? When the angle between the two vectors is considered to be 90 degree. So, case 3. When theta is equal to 90 degree. So, what will be the diagram like? This is A vector, this is point 2 and this is B. So, it will be like this. This is B vector. So, theta over here is 90 degree. Right? So, here if you substitute the value theta as 90, cos 90 is 0. So, resultant would be given by square root of a square plus b square plus twice ab cos 90. So cos 90 is 0, so we'll be left with a square plus b square. So whenever the two vectors are at right angle to each other, the magnitude of the resultant is given by square root of a square plus b square. Now regarding the direction, b sin 90 divided by a plus b cos 90. Sin 90 is 1, cos 90 is 0, so we'll be left with b by a. So this will give us the direction which the resultant makes with a vector. You can complete the diagram over here. This will be the resultant and this is angle beta. Clear students? So in case both the vectors are perpendicular to each other, this will be the magnitude of the resultant and this will give us the direction of the resultant, angle beta, which the resultant makes with a vector. Now let's try case 4. Case 4 is, students, when the two given vectors are of equal magnitude, then their resultant tends to bisect the angle between them. Right? So what we are going to prove that when magnitude of A is equal to magnitude of B is equal to X, say, then beta is equal to theta by 2. This is what we are going to prove, right? So consider this one. Tan beta, it's equal to, in place of B and A, we can substitute as X. X sin theta divided by X plus X cos theta. So we can write sin theta divided by 1 plus cos theta. What's the formula for sin theta? Yes, it is 2 sin theta by 2 cos theta by 2. Clear? 1 plus. What's the formula for cos theta? Cos 2 theta is 2 cos square theta minus 1. So cos theta would be 2 cos square theta by 2 minus 1. So cos theta would be twice cos square theta by 2 minus 1. So tan beta, it would be equal to 2 sin theta by 2 cos theta by 2 divided by 1 minus 1 get cancelled. We'll be left with twice cos square theta by 2. Cos theta by 2 and this square get cancelled. 2 get cancelled. So we are left with sin theta by 2 divided by cos theta by 2, which is equal to tan theta by 2. So compare both the sides. Tan beta equals to tan theta by 2, which implies that beta is equal to theta by 2. So students, always remember, whenever the two vectors are of equal magnitude, then their resultant will always bisect the angle between them. Clear students? So this is a very, very important result. Actually, you need to remember all the results, each and every result. So I'll give you an illustration. Let me give you an illustration. So this is what we have proved. Suppose this is a body and a force of 10 Newton is acting over here and a force of 10 Newton is acting over here, and suppose the angle between them is 60 degree. Now both the forces acting on the body at the same point are of equal magnitude. So if we intend to find the direction of the resultant, then we can make use of the result directly, which just now we have obtained. So the resultant in this case will bisect the angle between them. This is the resultant. It will bisect the angle, means it will make an angle of 30 degree with either of the two forces. Clear, students? This is 30 and this is also 30. So this is the result what we have obtained. If the two vectors under consideration are of equal magnitude, then the resultant always tends to bisect the angle between them. Here, in this case, the angle between them is 60 degree. So the resultant will make an angle of 30 degree with either of the two vectors. Clear? Okay. Case 5. This is a special case again. If both the vectors are of equal magnitude and they are inclined at an angle of 120 degree. This is the key. Both the vectors are of equal magnitude and the angle between them is 120 degree. Then the magnitude of the resultant is equal to the magnitude of either of the two vectors. This is what we need to prove. That is, if this is 10 Newton, if this is 10 Newton, and the angle between them is 120 degree, isn't it? So both the vectors under consideration are of equal magnitude, and most importantly the angle between them, theta, is 120 degree. Then what we are going to prove is that the magnitude of the resultant, it will be also equal to magnitude of either of the two given vectors. So in this case, the magnitude of the resultant would be also 10 Newton. And also in the previous case we have discussed, if the two vectors are of equal magnitude, then the resultant bisects the angle between them. So the resultant in this case will make an angle of 60 degree with either of the two given vectors, right? This is 60 degree, this will be also 60 degree. Clear, students? So this is what we intend to prove. So for that, let's consider this formula. The magnitude of the resultant of the two vectors A and B inclined at an angle theta is given by square root of a square plus b square plus twice ab cos theta. Now let's substitute the values in this special case. A, B, both are of equal magnitude, say x. So it will be x square plus twice x cos. Angle between them must be 120 degree. Now students, cos 120 degree. We all are aware of it. It is cos 90 plus 30. It will be equal to minus sine 30. It is equal to minus half. So let's substitute this value over here. So what do we get? X square plus x square. It will give us 2x square plus 2x square into minus half. Clear? So after solving, what you get is 2x square, 2 get cancelled, we will be left with minus x square. So it is square root of x square. Therefore, r is equal to x. So students, this is what we have proved. So do remember, whenever the two vectors are of equal magnitude and inclined at an angle of 120 degree, then the magnitude of the resultant is equal to the magnitude of either of the two given vectors. Right? So these are the special cases. Right? We have discussed all the feasible cases. So that's it for today's lecture. We have discussed the analytical treatment of parallelogram law vector addition. I sincerely hope that you all will remember the results, which are very, very important in solving numericals, and while encountering certain articles, we will have to make use of the results directly, which we have proved just now. Right? So we'll continue in the next lecture. Do join me in my next session. Till then, goodbye and take very good care of yourself. Thank you.